All right, today we're going to use the theme of a pool table because the pool table is engineered with calculus, and a vital part of calculus is implicit differentiation. So we picked the question, it's number 49 in the book, 3-7. Find the 2 points where the curve x squared plus xy plus y squared equals 7 crosses the x-axis, and show that the tangents to the curve at these points are parallel. What is the common slope of these tangents?
Look at that. Thank you. All right. First step in solving the problem. Here's your problem here. X squared plus xy plus y squared equals 7. You got to find where the x-intercepts are. Typically, one would set the equation equal to 0, but the equation equals 7, so you got to plug in 0 for the y's. So you plug in 0 here, and plug in 0 here, and it'll give you x squared plus x times 0 plus 0 squared equals 7. So these cancel, and it gives you x squared equals 7. Square root both sides. X-intercepts at negative root 7, positive root 7, right here.
All right. Here, we're breaking down the problem. We're trying to find the derivative of this equation here. So we need to use the power rule first on x squared, and that is going to equal 2x. And then you got to use the product rule here, which you can see how the product rule works here. It's u prime times v plus v prime times u. And here's a good way to set it up so you don't get confused on where to put the numbers. U equals x, and you're just finding the derivatives of them and putting them into this equation here, which we do here. So really there should be the 1 right here, but you don't need to put it in. So it's y plus y prime times x, and that's your product rule. And then on this y squared, you're going to use the chain rule and the power rule. So you bring the 2 down to 2y, and then you got to link it with y prime because of the chain rule.
We pity the fool who don't know the chain rule. All right. This next step here, we want to find the derivative. Like, we got to pull out the y prime to see what the derivative is, because y prime is the derivative. So what you're going to do is you're going to take every value that doesn't have a y prime connected to it, multiplication, and you're going to put it on the right. So you're going to subtract 2 over and subtract y, and it's going to leave you with y prime times x plus 2y times y prime equals negative x minus y. It's important to remember the negatives when you do these, because this is a plus, so you minus both of them. Next, you got to pull out the y prime. So you're going to pull it out, and it's going to give you y prime x plus 2y equals negative x minus y. You don't have to look at that right now. And so then, to get this alone, you're going to have to divide it over to this side, which I did here. I cross it out because that's after you do that. You cross it out. So you divide it over, and y prime will give you negative 2x minus y over x plus 2y. That's the derivative.
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 We're going to put a little spin on things today. All right. All right, so we already found that y prime equals negative 2x minus y over x plus 2y. Dakota figured that out. That's the derivative. All right, now that we have the derivative, we can plug the x-intercepts into our derivative equation. So we have plus or minus square root 7 we found for our x. So we plug them into these two equations here. We get the instant rate of change at negative 7, 0 is negative 2, and we also got negative 2 for square root 7, 0, comma 0. And that's how you find the parallels if you come back to the question, that's how we can ensure that the curve at these points are parallel.
The slope at the points are parallel.
Well said.